Hello, my wonderful chemists. We are continuing to talk about solutions, and today we're going to talk about solubility and solubility curves. So, even though we know sugar is soluble in water, for example, there's an extent to that solubility. So, at some point, if I add too much sugar, it's going to stop dissolving. So that's a measurable amount that we can measure, and it's called solubility. So the solubility is the amount of solute that will dissolve in a given solvent under given conditions. So for a certain set of conditions, if usually temperature, sometimes pressure, you can dissolve a certain amount. So these solubility curves kind of tell us how much of your solute you can dissolve in the given amount of solvent at these conditions. So we can form three different types of solutions. We can form a saturated solution, an unsaturated solution, or a supersaturated solution. So the word saturated means full. You know, if you have a sponge that is saturated, that means it's full, right? So saturated means that it's full of solute. So the solution contains as much solute as it can possibly hold under the given conditions of temperature and pressure. That's what a saturated solution would be. So if you were to look at our solubility curves here that tell us at different temperatures we can dissolve a certain amount, anywhere along those curves will be saturated solutions. So for example, if I had sodium nitrate and it is, let's say 30 Celsius, I could dissolve in 30 Celsius about 96 or 97 grams of sodium nitrate in 100 grams of water. So if I had 100 grams of water and I dissolved 97 grams of sodium nitrate, that would be a saturated solution, meaning it has the maximum amount that it can possibly hold at that given temperature. Now, if it's saturated or not, how would we know? Well, if it already has the maximum amount, then when I add more solute crystals, they should not dissolve. They'll just sink to the bottom. So that's how we can tell. Here I have a saturated solution, and it just looks like water, right? So I can't really tell if this is saturated solution or not. So what do? I add one more crystal and see what happens. And when you add one more crystal to a saturated solution, it just precipitates to the bottom and doesn't really dissolve. So add one more crystal of solute, should sink to the bottom and not dissolve. Okay, so just like you can have a saturated solution, maybe you have an unsaturated solution. So saturated means full, unsaturated means it's not full. So what does that mean? It has less than the maximum amount of solute that can be dissolved. So back to my solubility curve here. Let's say it's still 30 degrees and I still have sodium nitrate, and let's say I dissolved 80 grams. So that is less than the maximum amount. I could dissolve up to 97 grams, right? If I only have 80 grams dissolved, then that's not fully saturated, it's unsaturated. So anywhere below the line is going to be an unsaturated solution. It is not full. So if it's not filled to the maximum amount, what do you think would happen if I were to add one more crystal? Here's my unsaturated solution. It looks just like the other one, just looks like water. So what do? I add one more crystal, swirl, and see what happens. And if it's unsaturated, not full, then it's just going to dissolve. So my test here would be to do the same thing. Add one more crystal of solute. It should dissolve, because it's not full to the maximum amount. So we can have saturated, unsaturated. You can also have a supersaturated solution. That means it's super full. It has a greater amount of solute than you can possibly hold at that given temperature and pressure. How can that happen? Well, It doesn't happen with all substances, but some substances can form supersaturated solutions. For example, sugar with water can, but salt water cannot. So a lot of these solutes, when you increase the temperature, especially if they're solid, when you increase the temperature, you can dissolve more. Now, some of them, like NaCl, look at that. It's kind of like almost just a flat line. So that one, the temperature doesn't really affect its solubility very much. But look at something like sodium nitrate. If I increase the temperature, I can drastically increase the amount of solute that I can dissolve. Or potassium nitrate, same thing. And so what I could do is I could heat it up to a higher temperature, dissolve some more, and then I would cool down very, very slowly. And for some of these solutions, if I do this very carefully, they are able to keep that solute dissolved even when I go back to a lower temperature. So for example, let's say my room is 30 degrees and I have sodium nitrate. And the maximum amount I can dissolve is 97 grams. What if I want to dissolve 100 grams? So what I do is I heat it up until, let's say, 50 degrees. Dissolve my 100 grams. They can easily dissolve at 50 degrees. And then I let it cool down slowly back to 30 degrees. So when it's at 30 degrees, it's still holding the 100 grams, and so it's supersaturated. So anything above that line would be supersaturated. Again, not all substances do that, but some substances will, especially, like I said, sugar. So all candies are supersaturated solutions. Hard candy, caramels, fudge, all these are supersaturated solutions where you heat it up so that you can dissolve more sugar, and then you let it cool down slowly. So this is a supersaturated solution. Again, it just looks like water. So how can you tell? What do? Well, you add one more crystal, just like the other ones. In this case, though, if you add one more crystal, basically all of your solute will crystallize out. So add one more crystal of solute. The solution will crystallize. What does that mean? That means that once you disturb it, all the solute will come out of the solution and it's no longer going to be dissolved. Why? Well, in a supersaturated solution, remember, we heated it so we can dissolve more, and then we cooled it down slowly. So it's kind of like, let's say I am able to handle comfortably holding 10 books. So if you give me 8 books to hold, I'll be comfortable. I'm unsaturated. I can hold even more. So if you give me one more book, I'm good. I'll just keep going. Okay. What if you give me 10 books to hold? Well, that's my maximum. So I'm good with the 10 books. If you try to give me one more, I'm just going to not take it. I'm going to drop it on the floor. And I'm going to keep going with my 10 books. But let's say you very, very carefully put on me 12 books. Even though I can only comfortably hold 10. But I balance very, very carefully and keep those 12 books. Just barely, right? If you try to put one more book, more than the 12, that's already more than I can handle, I'm just going to crash and, all the books will fall, right? And so that's the idea here. Those solvent particles are barely holding onto those solute particles very, very carefully. If you were to disturb them in any way by either adding a solute crystal or by cooling it down very, very fast, or by scratching the surface or something like that, then it's going to crash and the solvent won't handle it anymore. It won't be able to hide the solute crystals anymore, and all the solute crystals will come out and crystallize. Now, the difference between the first one, where it sinks to the bottom or precipitates versus crystallize, you'll be able to tell the difference between those two because with the saturated solution, you'll just see the extra crystals just fall down. The rest of it will be dissolved. But with this one, you'll see the whole thing turn into almost solid. So let's test this with my substances here. So I'm going to start with, this is sodium acetate, and I have my 3 solutions here. This is unsaturated, this is saturated, and this one is supersaturated. So you can see they all look just like, you know, water, right? So what do? So I'm going to add a crystal or two to each of them of my solutes. So I added it to this one. I'm going to dissolve. And well, you can see that it all dissolved. Okay, let's look at my saturated one. So here it is. Again, it looks just like water. And I go ahead and add another crystal or two. And I'm going to swirl. And you can see it's not really dissolving. It's just sitting at the bottom, not really doing anything. Can you see those crystals right here? So that would be a saturated solution. It's already full. I can't dissolve anymore. Now let's look at a supersaturated solution. So this is my supersaturated solution. I'm going to open it and disturb it. And I'm going to go ahead and add one more crystal. Oh, and without even actually adding the crystal, you see that because I opened it kind of fast, it's already crystallizing. See that? That's pretty cool, right? I have another one, so I can show you, in case you missed it. Here's another one. Go ahead and watch carefully. And you can see it's starting to crystallize. See the needles of the crystal right here? Isn't that cool? So you can tell the whole thing is crystallizing versus my saturated one. Which one's my saturated one? I think it was this one. It was just sinking to the bottom. The whole thing wasn't crystallizing. And you can see like there's a tiny bit of liquid that can come out, but the whole thing for the most part is solved. So that's how you can tell if you have a saturated, unsaturated, or a supersaturated solution. Okay, so let's look more at these solubility curves here. And let's try to answer some questions. It says, what salt is least soluble in water at 20 Celsius? So we're going to go to 20 Celsius, and the one that is least soluble looks like it's KClO3. Okay, second question. How many grams of potassium chlorate can be dissolved in 100 grams of water at 50 Celsius? So we're going to go to 50 Celsius. We're going to go to potassium chlorate, which is this one right here. And it looks like I can dissolve 20 grams. Okay, next one. How many grams of potassium chloride can be dissolved in 200 grams of water at 80 Celsius? So I'm going to go to 80 Celsius, and I'm going to go to potassium chloride, which is KCl, so it's this one right here. And this shows me that I can dissolve about 50 grams in 100 grams of water. The question's asking me about 200 grams of water, so it looks like I can dissolve about 100 grams of KCl in 200 grams of water. Number 4 says, at 40 Celsius, how much potassium nitrate can be dissolved in 300 grams? So we're going to go to 40 Celsius. We're going to go to potassium nitrate, which is this right here. So at 40 Celsius, which is right there, looks like I can dissolve maybe 105 or so grams in 100 grams of water. The question's asking about 300 grams of water, so 3 times that would be, what, 315 grams. Question 5, which salt shows the least change in solubility from 0 to 100 Celsius? So the one that's showing the least would be the one that's the most flat, which would be the NaCl, meaning that no matter how much I heat it, I can't dissolve much more in there. Next one, number 6. At 30 Celsius, 90 grams of sodium nitrate is dissolved in 100 grams of water. Is the solution saturated, unsaturated, or supersaturated? So 30 Celsius, we're going to go to sodium nitrate. 30 Celsius, sodium nitrate. I can dissolve about 97 grams or so. We talked about this one already. They're telling us we have 90 grams dissolved. So if I can dissolve up to 97, but I only have 90 dissolved, that means it's unsaturated. It's not filled. I can put 7 more in there. Next question. A saturated solution of potassium chlorate is formed from 100 grams of water. If the saturated solution is cooled from 80 Celsius to 50 Celsius, how many grams of precipitate are formed? This one's a little bit more challenging. So they're telling us that we have a solution at 80 Celsius that is saturated. So we're going to go to 80 Celsius. We're going to go to potassium chlorate. So 80 Celsius potassium chlorate looks like I have 40 grams that are dissolved right now. It's telling me I'm going to cool it down to 50 Celsius. So right now I have 20 grams dissolved and it's saturated. I'm going to cool it down to 50 Celsius where I can only have 20 grams dissolved. The extra is going to precipitate. So it looks like this one's not going to form a supersaturated solution. It's going to precipitate. So how much would precipitate? Well, I originally had 40 grams dissolved. Now I only have 20 grams dissolved. So the difference between them, the other 20 grams, are what's going to precipitate. That's a tricky question. Okay, number 8. What compound shows a decrease in solubility from 0 to 100 Celsius? Looks like ammonia and also cerium sulfate. Now, with ammonia, ammonia is a gas. All gases will actually show a decrease in solubility when you increase the temperature. And we'll talk about why a little bit later on. With solid substances, most of them will dissolve more when you increase the temperature, but there are some exceptions, and so cerium sulfate is one of those exceptions. Okay, which salt is more soluble at 10 Celsius? So 10 Celsius, Ki looks like it's the most soluble. And then the last question, which salt is least soluble at 90 Celsius? So we're going to go to 90 Celsius, and it looks like cerium sulfate is the least soluble. So these solubility curves can help us decide what type of solution it is. If it's saturated, unsaturated, supersaturated, it can help us figure out how much I can dissolve at a given temperature and all kinds of different things. Notice again that all of these except for ammonia are solids. And so with the solid solubility, usually, not always, but usually, the higher the temperature, the higher the solubility. So most of them have a positive slope like this. Gases are the opposite. They have a negative slope, meaning that they dissolve more at a colder temperature. And there are some solid substances that are also the same way. Okay, have a great rest of your day. Bye.